This flower bloomed over 34 million years ago. Yet, despite its immense age, this fragile relic of the Eocene epoch is still preserved in near perfect detail, even to the point that if you zoom in close enough, you can find ancient microscopic pollen preserved within it. But how is that possible? In a word, the answer is amber, fossilized tree resin. Under the right conditions, amber can preserve intricate and delicate biological structures in incredible three-dimensional detail. And that's something that we are really fortunate for, because amber fossils are just absolutely wonderful. I mean, just look at this guy, look how incredible that is. In fact, amber preserves things like insects so well that pop culture's had a route in to try and sell you the idea that we can even extract DNA from them. Sadly, that seems to be quite unlikely in real life, as any DNA that is left in there is going to be far too old and degraded to do anything even close to the level of cloning that we see in Jurassic Park. But amber is still a powerful tool for helping us understand the ecosystems of ancient Earth, and this is where our ancient flower comes in. This is Symplocos kowalewskii, and it has been held inside this fossilized tree resin for tens of millions of years. It's from the Baltic region, which has one of the richest amber fossil deposits of anywhere in the world, and preserves things from the Eocene epoch, between around 34 and 56 million years ago. This fossil in particular, though, is most likely from the later part of the Eocene epoch, making it somewhere more like 34 to 38 million years old. And just look at it, just look how well preserved this thing is, despite its age. Look how clearly you can see the different features of the flower, like the petals, quite obviously, but also the staminate ring at the centre. That's what supports the reproductive parts of the flower, and also the anthers here. The anthers are the male part of the plant that produce the pollen. And the researchers who looked at this most recently in 2023 were actually able to extract and analyse pollen from this over 34 million year old plant. We're going to talk about that more in a minute, but first there's something else really cool that I want to show you from this. If you zoom in close enough, you can see other microscopic details preserved. The arrow on the right here shows a trichome, one of the tiny hairs on the plant that help protect it from different sorts of outside stress, both biotic and abiotic. And this one on the left shows something truly wonderful: preserved fungal hyphae, the remains of a fungus at least 34 million years old. I'm going to put that back on the screen so you can keep looking at it for a second longer, because that is just awesome. But this fossil is interesting for other reasons besides just being very well preserved. Flower fossils are really rare in amber. They only account for something like 1 to 3% of amber fossil specimens from the Baltic, and that level of rarity does seem to track around the other fossil amber deposits across the world. And this one actually is extra special because it's the largest one found so far. The flower itself measures about 28 millimeters across, which might not sound that big, but that's nearly 3 times the average size of other flowers found in Baltic amber. And you remember that ancient pollen that the researchers were able to extract from the amber? Analysis of that pollen actually led to a taxonomic reclassification of this fossil species, which might be interesting to some, just by itself, but it did have other interesting implications. When it was originally described in the 1800s, this species was originally called Stewartia kowalewskii, and it was assigned to the Taceae, that's the tea family within the Eocales order of the much bigger asterid group of plants. But the reclassification that came from the pollen analysis now puts it within the genus Symplocos. And that is relevant because while it is still within the Eocales order of the asterids, it's been moved to a different family, and that has interesting implications. Modern Symplocos tend to be evergreen trees and shrubs, found in both tropical and subtropical mountain forests in East and Southeast Asia. And that's not exactly what you picture when you think of the modern Baltic. That observation, in conjunction with other similar ones from other fossil finds from the Baltic, begin to paint us a likely picture of the environment of that region during the Eocene. It was possibly a warm and humid subtropical temperate forest with coastal swamps and bogs mixed in. So not entirely dissimilar from today, but also very different in some meaningful ways. Besides these insights into prehistoric climate, the new findings from the ancient pollen also add to a growing biogeographic picture about the family Symplocos belongs to, namely that it likely originated in Europe tens of millions of years ago, before then dispersing to its modern range in Asia. It was probably much more recent cooling and glaciation that pushed those types of plants out of Europe, and then leaving them only in their modern range in Asia. Isn't it just incredible how from a single delicate flower preserved for well over 30 million years, we can not only begin to reconstruct entire ancient ecosystems, but also track the movement of entire evolving plant lineages across the surface of the Earth? Yet for every insight we gain from a find like this one, there are still many more out there waiting to be found. That's all I've got for today. If you enjoyed this video, you might also enjoy one of my older ones about the evolution of caffeine that I'll put a link up there for. And also I want to take a moment to thank the channel's members for supporting this video. It's been a while since I've posted, but I'm hoping to upload much more frequently again over the coming weeks and months. And if you want to support the channel in that journey, you might even consider becoming a channel member yourself. Although, if not, absolutely fair enough. Just a like and a comment goes a lot of distance and helps me know if I'm on the right track with the sort of content I'm making and what you want to see, and if you find it informative. Anyway, thank you for your time.